This session we're going to take a tour of our solar system. A few sessions ago we toured the universe, so now we're going to come home and look at things more immediately around us. First of all, there's some things. This is an artist's conception, and the planets and the sun are all way too big. They're not to scale. But what I want you to see is that the solar system has some distinct parts to it. There are 4 inner planets around the sun. And then there's this band of Gradu here, which is little boulders and big boulders, and the asteroid belt. And then outside of the asteroid belt, we have other planets that are bigger. So the inner planets are rocky planets. They have hard surfaces. You can stand on the surface, and so they're called the terrestrial planets. The ones out beyond the asteroid belt are called gas giants because they, as far as we know, have no surfaces. They're great big balls of gas and liquid. So with that, we're going to start with the most inner planet, closest to the sun, Mercury. And I will talk in terms of their distances in terms of astronomical units, which is the distance from Earth to the sun, which is 93 million miles. Okay, so one astronomical unit, 1 AU, is 93 million miles. Mercury is 1/3 of an AU from the sun. That means it's 3 times closer than Earth. So you might think that it was be a little different from Earth. This is, again, it's Mercury, not our moon. And you see it's one pocked up thing. Mercury rotates very slowly, once every 59 Earth days, but it orbits around the sun relatively fast every 81 Earth days. But the combination of orbital speed and rotational rate results in an incredibly long solar day of 176 Earth days. So think of a pig on a spit. If you don't turn him fast enough, what happens to that side toward the fire? It gets extremely hot. And so that's what happens to Mercury. On the day side, it's 950 degrees Fahrenheit. Now, lead melts at 623, I believe, degrees Fahrenheit. The metal mercury in your thermometer boils at 670 some odd degrees Fahrenheit. We're talking 950 degrees Fahrenheit. That's really hot. And the day lasts 176 Earth days. So you're talking about months of high noon. On the night side, it's facing deep space through the intermittent Mercury nighttime, 170, half of that, 176 divided by 2. That's the complete rotation. So it's half of that, but it gets very cold on the night side, 346 degrees below zero. Most of the Earth's atmosphere would liquefy long before it reached that temperature. So Mercury is, I wanted to ask a question before we began. I'll back up. Why did we go into space to explore our moon and the planets? What was the reason for that? Do you remember?
Another place to habitate, to live.
Well, you remember the Cold War. It was a way of flexing our technological muscle and telling the Russians not to mess with us. But there was a more academic reason. There's an age-old question: are we alone in the universe? And a lot of people are interested in answering that question. So I bring that up because as we go through the planets, I would like you have an assignment. I want you to choose which planet you would like to go spend a weekend on. Everybody was quite sure that we would find life somewhere. So we'll go through here and we'll see what we find. By the way, that ridge there, as you see, it's a fairly long, about 60 miles. It's about as high as Montesano, about 1,000 feet, and that was a lava flow on Mercury. So Mercury is very cold on the side that's with the sun, and away from the sun, and very hot on the side toward the sun. And as it rotates, just imagine from high noon to midnight is over 1,300 degrees change. A lot of things can happen when you change the temperature that much. So Mercury's environment, no atmosphere, no oxygen, no liquid water, extreme heat, extreme cold. Who wants to sign up to go to Mercury? So let's go to Venus, the next planet out. It's 0.6 AU, about 2/3 of an AU, or about 240 million miles closer to the sun than the Earth is. So now this is what we're talking about, right? This looks a lot nicer, especially the inset up there in the right corner where it false color to accentuate the cloud patterns. And Saturn was at one time called kind of the twin of Earth. They're about the same size. And it looks kind of Earth-like with all those clouds. But if you strip the clouds away by imaging it with radar, it looks a little more sinister, doesn't it? And if you come down to the surface, it's not much better. You see huge lava flows from volcanoes. You have tectonic uplifts. And the atmosphere of Venus is 15 times denser than the Earth's atmosphere. And remember those cloud patterns? That's because there are winds on Venus. The winds blow constantly at something like 225 miles per hour. So you got 15 times the density at tremendous speed. Imagine the force of those winds. The atmosphere is 97% carbon dioxide. So what is that? It's a greenhouse, isn't it? So not only is it a third closer to the sun than the Earth, but it traps the sun's radiation very effectively. And those clouds that we saw that look so nice, they're clouds of sulfuric acid. That's, in case you don't know, that's a battery acid, like in the battery of an automobile. It will burn you if it gets on you. So things are not what they appear to be always. The temperature on Venus is a sizzling 900 degrees Fahrenheit. Now, Mercury was a little hotter, 950 on the sun side, but it was very cold on the night side. Venus is this temperature virtually everywhere because of the greenhouse effect. There's obviously no liquid water, and there's no oxygen. So you think about what would it be like to spend a weekend on Venus? And you know, to me, it sounds a little bit like Dante's Hell, does it? This heat. But the Russians put a lander on Venus back in 1982, Mariner 13. It landed successfully, took a few pictures, and died of heat stroke 2 hours and 6 minutes later. So even a robotic lander couldn't survive the acidic heat of Venus. So let's skip Earth a moment, and we'll go to the fifth planet, the fourth planet out, Mars. And let's spend a little time on Mars because it's always been a planet that interests mankind. Even back to the Roman days, they named this after their god of war, Mars. In the late 30s, I think it was 38, there was one of the first radio plays was Orson Welles' War of the Worlds. And it was put on as a play, and I think there were caveats at the beginning, but the play was put on as if it were news broadcast. So they would have this news broadcast, and then they would play some music, and they would interrupt the music for an update, a bulletin. And the whole thing, this is a story about War of the Worlds. It's invasion of Earth by creatures from the Red Planet. And they supposedly landed near Trenton, New Jersey, and they began to take over cities all over the earth, and they kept announcing these. And people believed so much that there could be life on Mars that people panicked. The chief of police of Trenton, New Jersey complained that their switchboard was completely crashed by the volume of calls coming in. It's reported that some people tried to commit suicide, other people were running around trying to find gas masks because supposedly these creatures were putting out gas. Why all this? Well, because the early telescopes saw the polar caps that you see here, and they saw that it had an atmosphere, and they thought they saw canals. And if canals, canal builders. And so people had bought into this. Well, the general public were not the only ones that thought there might be life on Mars. The scientific community also thought there would be life on Mars. Maybe not intelligent little green men, but at least microbial life. So let's look at Mars and see. Mars indeed has an atmosphere. It's a thin atmosphere, but it has an atmosphere. It has a lot of surface features. This is the Valles Marineris. It's dwarfs our Grand Canyon. It's over 100 miles wide. I think the Grand Canyon is roughly 8 or 10 miles wide. They have dust devils on Mars. This is looking down on a dust devil from orbit, and you can even see the shadow it forms on the surface there. This is a picture that was taken by one of the first two landers back in '76 of the surface of Mars, the first time we put something on the surface. And you can see there's not a whole lot of interest there. This is the latest lander we put down. This is Curiosity. Curiosity is about the size of a four-wheeler. It has a whole array of instruments. It's a traveling laboratory. And it's spent now, it was put there about a year and a half, 2 years ago. It's spent a good bit of time there now. This is the world's most expensive selfie, without a doubt. So here's where Curiosity landed, in Gala impact crater. And you know, impact craters, when something comes in, it hits the surface, and you have this rebound in the center. You always have usually have a center peak and then the ridge around the outside. So you see the center peak there on the right center of the picture, but in the background you can barely see the rim because of all the dust. Mars is very, very dusty. That's why it's a red planet. It has red dust, and sometimes they have dust storms that last most of a year. Here it is corrected for Earth light. So on the left you see what it would look like if you were standing on the surface of Mars looking at the wall of this crater. On the right is what it would look like on Earth in Earth's light. So you have quite a variation of terrain on Mars. Here's tracks from another rover, Opportunity. It traveled almost 20 miles to an impact crater to study it. You notice you don't see a single blade of grass in this picture, not one, as far as you can see. Here's Victoria impact crater. This is where it was traveling to. It spent almost 2 years here studying the rock layers and all things about the crater. And here are some features that have been seen from orbit that make it appear that Mars had water at one time. Particularly to me, the middle picture is exactly what I used to see in tide pools along the beach, where the water would run back over a little rise and back out into the Gulf of Mexico. It looks exactly like it. Here is teardrop islands, which are typically created when you block the water flow, and it prevents erosion directly behind a wall, and these are walls of these impact craters. So it looks like there was a flow from the lower right to the upper left. More layering that you tend to see with water. And here are rocks that appear to be sedimentary rocks. Like the top looks kind of like slate, and the bottom is called Martin blueberries. They're little round pebbles. If you saw that here on Earth, you would think that they were formed in a stream, wouldn't you? And we have erosion of crater walls. You can see it here, but especially here. Here's a picture that was taken about 3 years apart. The one on the left was taken first. And you see the crater coming, the gully coming down the wall of the crater. And on the right, 3 years later, you see that it's changed. It's obviously the same gully. You look at the top of it, there's no change at all till you get down where the arrow is, and there's new deposits there. So Mars is active. It's not a dead planet. Things are going on there. Here's something else. And you remember about a year and a half, 2 years ago, there was this big uproar in the news. We had discovered water on Mars. Well, I read the news report, and they're, as usual, they're not very, no offense, Tim, but they're not very helpful sometimes. So I got hold of a friend of mine at NASA headquarters, and he sent me some papers. And what happens is on the sun side of craters, some craters, not all craters, and gullies, you have these streaks that form, and you can see several of them here going downhill. So Mars has a warmer, I won't call it summer, but it has a less cold period and then an even colder period. And during the warmer part of the year, these streaks form, and they look like what you would see if you poured water down a sandy wall. They form, and then as it gets colder, they stop and they dry up and they disappear. Next year they come back. So that's what everybody got excited about. When I heard the report, I thought, wow, you know, we're ready to send astronauts and they can go up there and they can splash around in the pools and all this kind of stuff. Well, there was an imaging spectrometer on one of the orbiters. An imaging spectrometer is an instrument that can focus on a point, and it analyzes the light coming off of that point. So this could focus on the width of one of these streaks and analyze the light reflected off of it. And by doing that, you can tell what it is. All chemicals have their own light spectra, either emitted or reflected. Well, what they found out it is a hydride salt, they call it. In other words, it's even saltier than probably the Dead Sea. A very salty brine. It doesn't freeze where water would. It has a much lower freezing temperature. And so it can seep out and seep down the walls of these craters during a few months of the year, and then it disappears. There is no pool, there is no river, there is no ocean. There's nothing like that, just these seeps of very, very salty brine. So that's what everybody got excited about. And I find that interesting because when I first went to work at NASA, people really expected to find life on Mars. Now they're excited to find a salty brine. So Mars, look at the temperature range. A high of around 21 degrees below zero to a low of almost 200 degrees below zero. This is kind of the normal range of temperature. Obviously, there's no liquid water at these temperatures. So the atmosphere, it's 1/100th the density of Earth's atmosphere. So if you wanted to go to that density and try to breathe, you would have to go to something like 22 miles above the Earth's surface. Nothing lives 22 miles above the Earth's surface. And not only that, you see it's not oxygen, not a mixture of oxygen, it's carbon dioxide, no oxygen. So much for Mars. By the way, anybody want to go to Mars for a weekend? You might could live if you had a suit and took your own oxygen and a lot of heat. So the next planet, we jump over the asteroid belt and now we go to the giant planets. This is Jupiter. Jupiter is primarily a huge ball of hydrogen gas and liquid hydrogen. It has a tremendous mass. It's much bigger than Earth. In fact, it's so massive. Of course, the pull of gravity is proportional to the mass of a planet. So Jupiter is so massive that if you took a petite 100-pound lady and you put her up where the cloud tops are, if there was something she could stand on, she would weigh 265 pounds. She could be a defensive lineman for the University of Alabama. And thousands of miles down, there's probably a sea of liquid hydrogen. The temperature at the surface up there where she might stand is 171 degrees below zero. As you go down and things are compressed, it rises to an incredible 54,000 degrees. So Jupiter appears to almost have become a star, just wasn't quite massive enough to ignite the atomic reaction. So you notice Jupiter has these cloud bands. These bands rotate at different rates, and some of them even rotate in reverse. So Jupiter is this huge thing, 1,300 times bigger in volume than Earth. You could put 1,300 Earths inside Jupiter. And it's rotating, one day is only 10 hours. So it's rotating very fast. You imagine what happens to it. It becomes an oblate spheroid, and it causes these tremendous weather patterns to form, and the atmosphere is tremendously turbulent. So you see, here's what it looks like in real time. Not real time, I'm sorry, this is lapse time, but you can see that they're moving at different rates and different directions. And you see the swirl there in the lower hemisphere. That is the red spot of Jupiter. It's a gigantic hurricane that was first seen about 300 years ago and has never stopped. You could put both Earth and Mars into that hurricane at one time. So Jupiter, no liquid water, no oxygen, no surface, nowhere to go. Let's look at a couple of its moons. Io is the closest moon to Jupiter. It's only about 6 radii away. It rotates around Jupiter about every 18 hours, I think, day and a half, something like that. Io, this picture was taken by Voyager 1 back in 1979. And it's an interesting picture because you see in the upper left, there's something going on. That's a volcanic eruption. And at this time, it was thought that most of the bodies in the solar system are dead except for Earth. And here you have a volcanic eruption on one of the moons of Jupiter. Well, we know now that there are more than 400 active volcanoes on Io. Now Jupiter, I forgot to tell you, is about 5 times further from the sun than Earth. It doesn't get a whole lot of energy from the sun. So how do you get volcanoes on a relatively small moon? Io is about the size of our moon. Our moon doesn't have volcanic eruptions. What's going on here? Well, it turns out that Io has an oval orbit. So sometimes it's closer to the planet, sometimes it's a little further away. Jupiter has tremendous gravity. And so when Io comes closer, it gets deformed and it gets stretched. When it goes away, it goes back to a spherical shape. Comes back, so you have this tidal stretching that happens every orbit. And that causes the rocks to heat. And eventually, there are pockets that get hot enough that they liquefy, and like on Earth, they make their way to the surface and they erupt, and that plume there is about 60 miles high. So what is it that erupts? Well, it's various sulfur compounds. Particularly the gaseous stuff is sulfur dioxide. Think rotten eggs. So this is not only an ugly place, but it's a very smelly place. This is Europa. It's the next moon out. It's about the same size, a little bit smaller. It has one of the smoothest surfaces in the solar system. It has a lot of cracks. And so if we go down to the surface, you see here's where a meteor has hit it, and it caused this dimple in it. What does that look like?
Broken glass.
Broken glass, or maybe ice. Turns out it's ice. Europa is covered by water ice. And we got so excited about that little drip on Mars. It's covered by water ice, and you'll notice that there are no big craters. There are a lot of cracks, but no big craters. Well, Europa's gotten hit by everything everybody else got hit by. Why no big craters? Because if you have an ocean underneath a layer of ice, a big meteor will go through the ice, and it'll fill back in and refreeze. So you don't have any big craters on Europa. You have little teeny ones. You can see, well, I can't point to it. You can see one there kind of just below the S in crevices down there, but they're not big. But you have all these cracks and strange double ridge cracks and all this. But so it's thought that there's an ocean of liquid water underneath the ice on Europa. A few years after this, they were doing a study with the Hubble telescope, and they actually saw plumes of water vapor escaping from Europa. So it appears that there is water on Europa. This is 2.5 miles across this picture, so you see that these structures in the ice are fairly sizable. Well, let's go to Saturn. We haven't found a good place to light yet, so Saturn. Known for its rings, but the planet is very much like Jupiter. It's a giant ball of hydrogen, mostly hydrogen gas. No liquid water, no solid surface, no oxygen, and the rings are made out of basically water ice for the most part. And there are literally tens of thousands of rings. It reminds me of an LP record. I guess that dates me, but they're just tremendous number of rings. They're beautiful. Here they are at an angle so that you see the shadow of the rings on the planet. But Saturn is really no different from Jupiter, so it wouldn't be any more hostile to life than Jupiter is. But it has an interesting moon, Titan, you see in the background here. Titan is the only moon in the solar system that has an atmosphere. And it's covered by clouds continuously. So until a few years ago, when the Cassini mission got there, nobody had ever seen the surface of Titan. Total mystery. The Cassini carried radar imaging, and it also carried a probe, the Huygens probe, that was put down on the surface. It's actually parachuted down because of the atmosphere is fairly thick. And on the way down, it saw some pictures, took some pictures that got everybody very excited. What does this look like? Looks like a river, doesn't it? Coming out of the highlands and dumping into a sea. And that's what it is. When they got to the surface, they found out that appearances can be deceiving. The temperature on Titan is 290 degrees below zero. And that's on a good day. So our atmosphere, again, would be, most of it would be solid at this point, except maybe the nitrogen. The atmosphere is 95% nitrogen, 5% methane, and ethane. So it's smog. It's a very, very cold smog. It has rivers and lakes, and it has rain. Actually has rain, only it's not water. It's liquid methane and ethane. It has rocks, which are not silicon like they are here. They are frozen water, perpetually frozen rock hard. It has sand dunes made of hydrocarbon sand. Everybody got excited about Titan because there's just tremendous number of hydrocarbons here, and they thought surely there would be life. No life. Going on further out, here's Uranus. It's interesting. We don't know much about it. The Voyagers didn't go by there, but it's flipped on its side. It rotates in its orbital plane rather than like we do. Our axis is almost vertical to the plane. Titan. Uranus turns this way. Neptune, next planet out, is again one of the gas giants. It has clouds. It has an ocean, apparently, it's thought about 6,000 miles deep, of scalding hot water and ammonia. And Saturn was like 10 AU from the sun, 10 times the distance the Earth is. This is much further out. So there's very, very little energy from the sun here. So how do you have a scalding hot ocean? Well, it has a core about the size of Earth that's radioactive. And it's the radioactive decay from the core that's heating the ocean, not the sun. Again, not a friendly place, and I'm stuck. Oh, there we go. There's one of the moons of Titan, of Neptune, I'm sorry, that's Triton, moon of Neptune. Triton is just a real frozen ball. That's nitrogen ice, not water ice, much colder than water ice. Water ice is actually pushed up through these cracks, is what makes this cantaloupe-looking structure. And then Pluto, which has unfortunately lost its planetary status, but we'll talk about it anyway. This is Pluto with a couple of its moons in the picture. Until a few years ago, this was the very best picture of Pluto we had. It's so far away, even the Hubble telescope can't resolve it very well. You can tell there's something there, but it's just basically a fuzzy white ball. Until about last year, we sent a probe by Pluto, and we got a first good picture of it. And maybe instead of being named after a dog, it should be named the Love Planet. So we're going to go down near the left lobe of the heart there, and we're going to look at the surface. And what that heart is a continental-size ocean of nitrogen ice. Not liquid, but ice, with liquid below it. You see mountains and blocks where the ice is broken up. Here's even the closest picture, and those mountains you see on the left are mountains of water ice, maybe a mile and a half high, and you have these blocks in the ocean, the flat part. That's the nitrogen ice, and what's going on there is something similar to a lava lamp. As you go down, the planet gets warm enough toward its deeper that it keeps the nitrogen liquefied. And so the warmer nitrogen comes to the top, and then you have this downflow, and so it forms these cells like this. We don't have any idea what this is. If you look at what looks like a lake about halfway up on the right side, you see that flat place? See those rugged shadows on that lake? No idea what that is. It's a lot of mysteries. Pluto, surprisingly, has a kind of primitive atmosphere. It's not what you would think. I would not actually call it an atmosphere because it's transient, but the nitrogen on the oceans is evaporated. It's not evaporated. It doesn't melt. It goes straight from a solid to a gas, and the gas is escaping the planet. And as it escapes, it forms this atmosphere, they call it. So, coming back to Earth, Genesis says, now the earth was formless and empty. Darkness was over the surface of the deep, and the Spirit of God was hovering over the waters. Reminds me a little bit of Pluto. But the question we want to look at is, what was God doing hovering over the waters? And that's what we'll look at next when we come back next session, the special nature of Earth. And I think you'll really be surprised.